Hello everyone, hope all of you are safe and healthy. Welcome to IASbaba's Rapid Revision Series for Prelims 2021. This is session 50 and day 68. And the topics we have are the science and tech, basically the chemistry. So these are the hot topics we are going to discuss, that is the nuclear enrichment, and then the polymetallic nodules, and the rare earth metals, and acute encephalitis syndrome, and then the glyphosate and why was it banned in Telangana, and the Dicaphol and the Perfluorooctanic Acid, and then the CFC, HFC and PFC, and the Kigali agreement regarding the chlorofluorocarbons, hydrofluorocarbons and the perfluorocarbons, and then the difference between osmosis and reverse osmosis, and then the lithium ion technology and the zeolites. Now coming to the first one, the nuclear enrichment. Friends, we know that some of the metals, they occur in 2 to 3 forms and they are called isotopes. And for example, uranium, it occurs in 2 forms, that is uranium 238 and uranium 235, we know that. And the uranium 238, it has 92 protons, 92 electrons and 146 neutrons. And if we remove 3 neutrons from this, we get 92 electrons, 92 protons and 143 neutrons. But however, this 143 neutrons is not so stable, and this uranium 235, it tries to attain stability by giving out as many protons and neutrons as possible and getting back to the lower radioactive element or the lower stable element. For example, uranium 235 will continuously emit radioactive emissions and it will get back to thorium or plutonium, which are the lower radioactive elements. So this is how the radioactivity works. Now, how to enrich the uranium? Friends, we have to basically remove the neutrons from the nucleus and then induce radioactivity, but that is a cumbersome process. So it is very hard to cut open the shells of these electrons and then get into the nucleus and then remove the protons or neutrons. But however, we have found some easy methods, that is, we know that in the natural uranium, some 1 or 2 atoms will be containing the atoms of uranium 235. So here we can see in the natural uranium 238, 0.7% of uranium 235 will be naturally present, and we will cache on this. So increasing the density of this uranium 235 will be sufficient for enrichment of uranium. So here we can see that adding 2 to 3 more molecules of uranium 235, we got 3 to 5% of enrichment. So likewise, we start from the single molecule and then we go to 3 to 5% and then we go to 20% and then we go to 90%. But how to increase the density of this uranium 235 within the given amount of uranium element? So these are the processes, and the basic one is the centrifuge process. So here friends, in the centrifuge, the centrifugal force will be in action. So what is centrifugal force, friends? So when we rotate a stone by tying to a thread, then it will exert a force away from our hand, and this is a centrifugal force, and centripetal force will be towards our hand. So this centripetal force will be handled by the thread and this centrifugal force will be acting on the stone, and heavier the stone, the more will be the centrifugal force. So heavier the stone, once it cuts off, the farther it will go. The same principle will be applied here also. Friends, we know that uranium 238, it consists of 146 neutrons. But however, uranium 235, it consists of 143 neutrons. So automatically the uranium 238 will be heavier. You agree with me? So this heavier atom, it will hit to the farther distance when they are rotated in the high speeds, and this uranium 235, which is a lighter atom, it will lie in the middle of this centrifuge. So now what I do is, I take a pipe and I will insert it in the middle of the centrifuge. So here most of the atoms will be uranium 235, and when I suck the airs from this, I will get most of the uranium 235 atoms. So likewise, when I suck this air, the 90% of the atoms will be of uranium 235. So automatically I have enriched. So my given amount of uranium, it consists of most number of uranium 235 and least number of uranium 238. So this is how the enrichment is done. So every time the nucleus is not broken and the neutrons or protons are not taken out. So this is all about the nuclear enrichment, and this was in news because of the Iran nuclear agreement. Then come to the next topic, the polymetallic nodules. Friends, polymetallic nodules was in news because of the India's deep ocean mission. Now coming to the key points of these polymetallic nodules. Polymetallic nodules are also known as manganese nodules because manganese is prominently present in these nodules. Then they are potato shaped, largely porous nodules found in the sea floors. So these are basically present in the sea floors and they are potato shaped, basically the oval shaped nuggets. Then besides manganese, they also contain iron, nickel, copper, cobalt and lead. So almost all the metals are present based on different proportions. Then coming to the significance of these polymetallic nodules, they contain rare earth elements and metals. So even the rare earth elements are present. And what are these rare earth elements? We will discuss in the further slides. Then the amount of copper contained in the nodules is estimated to be around 20% of that held in the global land based reserves. So 20% of whatever copper that is present in the land that are present in the polymetallic nodules. So huge reserves are present, we can cash on them. Then there are great sources of valuable minerals such as gold, silver and zinc. So not only nickel, cobalt, etc., even gold, silver and other precious metals are also available via polymetallic nodules. Now coming to India and polymetallic nodules. Friends, India is the first country to have received the UN permission for exploration and utilization of these polymetallic nodules, and India had signed a 15-year contract for the exploration of these polymetallic nodules in the Central Indian Ocean Basin. So this Central Indian Ocean Basin is worth remembering, and this was signed with the International Seabed Authority in 2002. And in 2016, this 15-year agreement was finished and India got extension of this contract up to 2022. So this is the status of the agreement right now. Now coming to more facts regarding the polymetallic nodules. Friends, how these are formed? So basically the marine organisms and the marine flora and fauna, they deposit these elements and metals in minute amounts. So these minuscule amounts of metals, they get deposited on the seafloor and slowly they get crystallized and concentrated to form nodules. So there are various elements and metals that are being deposited. We know that golds will be deposited by bacteria, then silver will be deposited by some others, then iron will be deposited by most of the marine organisms. So likewise, various metal elements, they come and get deposited. That is why most of the metals are found here, and that is why the name polymetallic nodules, that is polymetals are present. Now how to find out what types of metals are present? So here we can use the nanospectroscopy or the Raman spectroscopy or any others. So when we use a spectroscopy, here we can see various metals present. So here we take a sample of polymetallic nodules and we subject this to spectroscopy. Firstly, iron will be present in the form of layers. Friends, here we can see various layers of black ones which are showing the iron content. Then manganese are also present in the form of layers. So here we can see some green layers of manganese. So this iron and manganese are prominently present in these polymetallic nodules. But however, magnesium is present in a very trace amount, and here this reflected light, they depict the magnesium content, and even silicon are present and they are present in a significant amount. We can see the reflected light here, and even sodium is present significantly, and even aluminum is present to some extent, and calcium is also present. But however, other metals like titanium, potassium, nickel, etc., they are present in a very trace amount. That is why we hardly see any reflections here. So likewise, any metals that are present, they are subjected to this chromatography and spectroscopy. So we can detect them and we can extract them with the specific processes. So this is how the polymetallic nodules are extracted, and this is how they are visible to the bare eyes. So for the human eyes, they are visible like potatoes. So this is all about the polymetallic nodules. Come to next topic, the rare earth elements. Friends, we know that this is the periodic table, and here the elements present in this column, they are called the rare earth elements or the rare earth metals. Friends, why they are called rare earth metals? Because these are available only via salts of potassium and sulfate. They are not available in the free form. And here we can see aluminum, zinc, copper, nickel, etc. at this part of the periodic table, and these are available and these have the stability to exist in the free form. But however, these are more reactive than these metals, and that is why they are not available, and as they are not available freely, they are considered as rare earth elements in the past, and even today the name is continued, even though we have various techniques to extract these metals from those sulfate and phosphate salts. And now friends, this 57 to 71 element or the 57 to 71st cell in the periodic table, this is prominently the rare earth element. So this is called the lanthanide series, and almost all the elements present in the lanthanide series, they constitute rare earth metals, and they have specific chemical formula which almost resemble to each other. But however friends, we also have one more cell below this lanthanide series, and this is called the actinide series. Friends, why actinide series are not included under this rare earth metals? Because most of the elements present in the actinide series, they are industrially produced. So, they are not present in the earth automatically. So, as they are not the earth metals, they cannot be called as rare earth metals also. They can be called as rare metals, but they are not rare earth metals. So, this is how this actinide series are excluded and lanthanide series are included in the rare earth elements or rare earth metals. Now, coming to more facts regarding the rare earth metals. Friends, the rare earth elements or the lanthanides are a set of 17 nearly indistinguishable lustrous silvery white soft metals. So, these are the physical properties. They are lustrous, that is, they have the luster or they shine in the sunlight. Then they are silvery white in color. They are soft metals and they are heavy metals also. Then, despite their name, rare earth elements are relatively plentiful in the earth's crust. So, we know that these are present in the salts, but these salts are in plenty. But earlier, as these are not being extracted so easily, they were called rare earth metals. But however, today we can extract rare earth metals sufficiently. Then, scandium and yttrium are considered rare earth elements because they tend to occur in the same ore deposits as the lanthanides and exhibit similar chemical properties. So, this scandium and yttrium which were present above, so these are the scandium and yttrium atoms, and these are also included in the rare earth elements because they are available in the same ore where the lanthanides are available, and they also exhibit similar chemical properties. Then what are the chemical properties? In the pure form, these rare earth metals, they get tarnished slowly in the air at room temperature. So, they react with the air and they get converted into oxides. So, just like how silver, copper, etc., they get tarnished, even these metals, they get tarnished. Then they react slowly with the cold water to form hydroxides and they liberate hydrogen. So, with the cold water, they react and they form hydroxides. Then they react with the steam to form oxides, and at the elevated temperature they ignite spontaneously and burn with a fierce colorful flame. So, with the heated temperature they catch fire automatically and they burn in a colorful flame, and as a result of that they give out oxides. Then the water soluble compounds are mildly to moderately toxic, but the insoluble ones are not toxic. So, these are both toxic as well as non-toxic. So, which are water soluble are toxic in nature, and that too moderately. Then rare earths have diverse applications in the electronic and electrical components, and then laser industries, glass industries, then magnetic material and the industrial processes. So, in all these areas, these have the applications. So, this is a brief account on rare earth metals. Then come to next, the acute encephalitis syndrome. Friends, what is acute encephalitis syndrome? It is a disease characterized by high fever and altered consciousness. Friends, what is altered consciousness? It is that for some time you will be awake and for some time you will go unconscious. So, this switching on and switching off between consciousness and unconsciousness is called altered consciousness, and these are present prominently in the children below age of 15 years. And then what was the cause of this acute encephalitis syndrome to break out in India? Friends, we know that this was due to cause of eating lychee fruit. Friends, methylene cyclopropyl glycine, also known as hypoglycine A, is known to be a content of lychee fruit. So, this lychee fruit, it contained methylene cyclopropyl glycine or the hypoglycine A, and undernourished children who ate lychee during the day and went to bed on an empty stomach, they presented with serious illness in the early morning. So, this lychee fruit or this methylene cyclopropyl glycine was the cause of this encephalitis. Then the toxin in the lychee, that is the MPCG, it lowers the blood sugar level during the night, and these children are found unconscious in the morning. So, the main action is it lowers the blood sugar level, and then the blood glucose falls sharply, causing severe brain malfunctions. So, as the supply of glucose, it stops to the brain, and this brain, it stops functioning, and it leads to seizures, coma and sometimes even death. Then come to more facts regarding the acute encephalitis. If toxins from lychee were causing hypoglycemia or the lack of glucose to the brain, then it should have affected children of all socio-economic strata. But in the contrast, this year all deaths have been recorded in the lower income groups. So, only those poor children, they were affected with this encephalitis. Then, while well-nourished children eating lychee remain unaffected even if they go to bed on an empty stomach. So, even if they go to bed on an empty stomach, these rich people, they didn't experience encephalitis. Then this is because undernourished children, they lack sufficient glucose reserve in the form of glycogen. Friends, because of undernourishment and malnutrition, these poor children, they lack fats and they lack adipose, and as a result they lack glycogen reserves or the glucose reserves which were stored in the body. Then also the production of glucose from non-carbohydrate sources is unsustainable and thus stopped midway. Friends, we know that if we do not have this glucose reserve, then the blood tries to extract this glucose via protein cells or via proteins. So this non-carbohydratic source, it occurs via anaerobic respiration. But this anaerobic respiration will not be sustainable. It cannot sustain for longer time. So after some time, even this will stop. So now this anaerobic respiration also stopped and there is no glycogen and there is no glucose in the blood. As a result of that, the brain will stop functioning. So this is how the poor children, they experienced acute encephalitis syndrome when they ate lychee and they went to bed with the empty stomach. So this is all about this AES. Then come to the next topic, the glyphosate. Friends, we know that recently Telangana government, it banned controversial herbicide glyphosate. So we discuss why it was banned and what was the issue regarding this glyphosate. Friends, the glyphosate is a controversial herbicide usually used to kill weeds in the cotton farms. So these are herbicides or weedicides. They are used in the cotton farms. Then the usage of glyphosate is banned because it is carcinogenic. So this is cancer causing agent. That is why it was banned. And also it is being banned to control the illegal cultivation of HTBT cotton. So in order to control this herbicide tolerant BT cotton, this was banned. So the two reasons why it was banned was, that is, the glyphosate itself is harmful and also that it is associated with the HTBT cotton. We will see how it is associated later. Then the glyphosate is absorbed through foliage or the plant leaves. So this shoot system and leaf system, they will absorb the glyphosate and they are minimally absorbed by the roots. So roots will not absorb glyphosate to that extent. Then in 2015, World Health Organization classified glyphosate under category 2A. That means it is a probably carcinogenic in humans. So not surely but probably it might be carcinogenic. So this is what the status given by WHO and this is worth remembering. Then why do farmers prefer HTBT cotton? Friends, a normal cotton grower, he spends 20 to 25% of the expenditure on growing the cotton in removing the weeds. But on the other hand, this HTBT cotton farmers can save this expenditure on weed management. Friends, we know that this HTBT cotton are herbicide tolerant. So they are tolerant to this glyphosate also, which is a herbicide. And now if I spray this herbicide on the cotton farm, almost all the cotton plants, they will survive and the weeds will die off. But however, if I spray the same for other varieties of cotton, then even the cotton plant will be destroyed. So that is why if you want to grow herbicide tolerant BT cotton, then glyphosate can be used easily. And if you ban glyphosate, then growing HTBT cotton or growing any other variety of cotton, there will be no difference at all. And now reason for the ban. The Generic Appraisal Engineering Committee or the GEAC has not yet approved HTBT cotton. So these Telangana farmers, they are growing HTBT cotton illegally. So if you want to stop this HTBT cotton growth, we stop glyphosate and automatically HTBT cotton will also be stopped. Then the glyphosate leaches into food and water and causes chronic kidney diseases in humans. So it is not only that HTBT cotton is illegal, the glyphosate is also specifically harmful for the human health. And then the glyphosate is also used as crop desiccant. Friends, crop desiccant is that which kills out the leaves in the plant. So it kills the leaves and shoot system and allows the plant to go dry. As a result of that, the plant will die off. So almost all the weedicides and herbicides, they act the same way. It need not be glyphosate per se. So this is all about the glyphosate. Then come to next, the Dicaphol and Perfluorooctanic Acid. Friends, these were in news because these two chemicals, they were the latest addition to the Stockholm Convention of Persistent Organic Pollutants. So here in the figure, we can see Dicaphol, which was added in the year 2019 and this was the latest one. Now coming to Dicaphol. Dicaphol is an organochlorine pesticide that is chemically related to DDT. Yes friends, even DDT is also a organochlorine. It is a compound of carbon and chlorine. We know that in the same way Dicaphol is also a organochlorine compound. Then WHO classifies Dicaphol as a level 2 or a moderately hazardous pesticide. So this is moderately hazardous as per WHO and it is not extremely hazardous. So this is a point worth remembering. and then it is used as foliar spray on agricultural crops and ornamental crops. So both for the agriculture and show crops, this foliar spray or the spray on the shoot system and leaves, it can be used. And in domestic buildings also, they are used to control the ticks and mites. So these are mainly miticides and ticicides. Then Dicaphol is a nerve poison. It causes hyperstimulation of nerve transmission along the nerve axons. So in the nerve cell, this will hyperly activate the synapse or the chemical that results in transmission of neural messages. Then the symptoms of ingestion and respiratory exposure include nausea, dizziness, weakness and vomiting. So if you consume this or if we inhale this, then we experience this vomiting and other symptoms. Then dermal exposure may cause skin irritation or rashes. So if our skin get exposed to this Dicaphol, then it causes irritation. And if eye is exposed, it causes conjunctivitis. Friends, conjunctivitis means the watery eyes and other allergic symptoms. Then poisoning may affect the liver, kidneys or the central nervous system. So liver, kidneys and the brains are also affected by this Dicaphol. Then Dicaphol can be stored in fatty tissues. Hence, intense activity or starvation may mobilize the chemical, resulting in reappearance of the toxic symptoms long after the actual exposure. So this Dicaphol, it will be stored in our fat. So after starving, this will reappear and this will re-exhibit its symptoms. So this is all about the Dicaphol. Coming to next, Perfluorooctanic Acid. Friends, even this was the latest addition to the Stockholm Convention, and here in the figure we can see how perfluorooctanic acid, it was added in 2019. Now it is produced and used worldwide as industrial surfactant in the chemical processes. Friends, what is the meaning of this industrial surfactant? Surfactant is a one which reduces the surface tension of a liquid. So this surf, then Rin Supreme and other detergents, these are surfactants because they reduce the surface tension of water, and as a result of that, this water can enter into the nooks and corners of the cloth and it can remove the dirt. So all those detergents, they are industrial surfactants, and even this perfluorooctanic acid is also a surfactant. Then it is a water and oil repellent. So due to this property, it is used in fabrics, in leather industry and production of floor waxes and waxed paper. So where and all these water repellent properties are used, so in all those industries, this perfluorooctanic acid is also used. Then the compound is also used in insulators of electric wires and in the planar etching of fused silica and firefighting foam and outdoor clothing. Friends, we know that insulators of electric wires means the plastic insulators. Then the planar etching of fused silica means there will be fused silica element, and in this fused silica some planes will be specifically etched and some circuits and others can be embedded in these grooves. So that is how the planar etching is done, and this perfluorooctanic acid can be used to etch those parts of the plane. Then they are used as firefighting foams as well. So they are used as fire extinguishers. Then they are used for outdoor clothing. So just like the technical textiles, these are also used. Then perfluorooctanic acid has been detected in the blood of more than 98% of the general US population. So up to a huge extent of 98%, this has already entered the human food web. Then the perfluorooctanic acid has been detected in the industrial waste, and it is in the stain resistant carpets, then the carpet cleaning liquids and house dust and microwave popcorn bags, then water, food and Teflon products. So in almost all the household products, this PFOA is being present. Then effect on the health, this perfluorooctanic acid, it causes kidney cancer, testicular cancer, then ulcerative colitis, that is the ulcers in the colon, that is that part which is above the rectum. So in the large intestines last part, this colon is present, and there if ulcers are made, it is due to this perfluorooctanic acid. Then thyroid diseases, so this will also result in inefficient thyroid, and that results in less secretion of thyroid hormones. Then hypercholesterolemia, so this is where the hypercholesterol will be deposited in our body. So excess of fats will get automatically deposited in whatever we eat. Then pregnancy induced hypertension. So hypertension during pregnancy is also an effect of this perfluorooctanic acid. So the hypertension induced during pregnancy is also due to this perfluorooctanic acid. So this is a brief account on Dicaphol and perfluorooctanic acid. Then come to next one. the CFC, HFC and PFC. Friends, we know that these are a part of Vienna Convention, Montreal Protocol and also the recent Kigali Agreement to Montreal Protocol. So now, what is this CFC? These are the chlorofluorocarbons, or those structural carbon compounds wherein two sides of the carbon will be attached with fluorine and the remaining two sides with the chlorine. So, these fluorine-chlorine carbon compounds are called chlorofluorocarbons, and these are the main cause of ozone layer depletion. Yes, we know that. Then these are released by the solvents, that is the Dettol and other solvents, then the spray aerosols, the air fresheners, the deodorants and others, then refrigerators, that is the fridges, then air conditioners. So, all these are the sources of this chlorofluorocarbon. Then the molecules of chlorofluorocarbon in the stratosphere are broken down by the ultraviolet radiations and release chlorine atoms, and these atoms react with the ozone and destroy it. So, here we can see the reaction how it occurs. So, this chlorine, it is being induced by action of ultraviolet rays on the chlorofluorocarbon, and this chlorine will readily react with the ozone atoms, and that lead to destruction of ozone molecule, and the ozone molecule is split into O2 and chlorine monoxide. So, this chlorine monoxide, this further reacts with the monoatom oxygen, and that causes the oxygen O2, and further this chlorine will be reformed. So, this chlorine will be once again ready to act on another ozone molecule. So, one chlorine molecule, it can destroy thousands of ozone molecules. So, that is why it is highly dangerous, and as a result of this excessive chlorofluorocarbons, we experienced huge depletion of ozone layer and many holes were formed. So, that is why Vienna Convention was made, and we agreed in the Montreal Protocol that in almost all the countries of the world, we are going to ban this chlorofluorocarbon. And then these hydrofluorocarbons, they were used as substitutes to chlorofluorocarbons. They had the similar chemical properties and similar applications, but recently even these are found to be acting against the ozone layer, but not directly but indirectly. So, we will see how. Before that, this is the structural formula of hydrofluorocarbons. There we have carbon compounds with the fluorine attached, and in some areas hydrogen is also attached. So, here there is no chlorine but only the fluorine and hydrogen. Then hydrofluorocarbon gases indirectly contribute to ozone depletion, that is the HFC emissions, they cause increased warming of the stratosphere. So, potentially these HFCs, CFCs, they all have the property to absorb this infrared radiations, or they are the potential greenhouse gases, and these greenhouse gases, they automatically heat up this stratosphere. Friends, we know that the stratospheric clouds, these are the main substrates for the chemical reaction against ozone. So, when we heat these stratospheric clouds, automatically the reaction will be enhanced and more depletion of ozone takes place. Then, and they also decrease the ozone levels in the tropics by accelerating the upward movement of ozone pore air. So, these greenhouse gases, they deplete the ozone in the tropics as well. And when the tropics are near the earth's surface, if the ozone is depleted, then the same air moves upwards, and even that do not contribute much for the ozone layer. So, that is why day by day this ozone starts depleting. So, that is how indirectly this HFCs, they are also acting against the ozone layer. So, that is why in the Kigali Agreement of Montreal Protocol, we agreed that we are going to phase out this hydrofluorocarbons also. So, this is the status as of now. Now, coming to perfluorocarbons. Friends, perfluorocarbon, they have a unique property, that is they are breathable liquids. Friends, what is the difference between breathable and non-breathable liquid? Friends, as you know, the human beings, like many other animals, are incapable of breathing liquid media. So, we cannot breathe water, but however, fishes can breathe water. Friends, that is because we cannot get oxygen from the water that quickly enters our lungs. So, once the water enters the lungs, so that will not give out the dissolved oxygen, but in the fishes, that water will not enter quickly, and by the time they enter, they give out the dissolved oxygen. But however, this perfluorocarbon, this gives out oxygen before it enters the lungs. So, that is why this perfluorocarbon liquid can be breathable. Just like any others, even mammals can also breathe this perfluorocarbon, and then it is a product with great chemical stability. So, it is highly chemically stable and it is capable of absorbing gases. So, this gas absorbing property is used for various areas, that is in the refrigeration appliances, then waterproofing, then containers for microwaves and others, and it is also used as medicines. So just because it absorbs various gases, then it is used in refrigeration to absorb any gases that are leaked. Then they are also used in waterproofing to suck up all the water molecules and dehydrate the environment. And it is also used in microwaves. Here also it sucks up all the excess gases that are being leaked. Then it is also used in medicine. So if there are any harmful gases in the body, this can absorb them. So that is how they act as medicine also. Then coming to the ill effects of perfluorocarbon. Friends, they are potential to global warming. Yes, just like the hydrofluorocarbons, these are also GHG gases. Then they do not accumulate in the body, so they are not bioaccumulators. But however, these fluorosurfactants, these are bioaccumulators. Friends, we confused with the perfluorocarbons and the fluorosurfactants. Friends, fluorosurfactants means those perfluorocarbons on which some alkaline molecule is attached. So here we can see a perfluorocarbon, and if alkaline elements like aluminium, then germanium or even silver, like alkaline substances, if they are attached, then this molecule will turn into this perfluorosurfactant. But however, perfluorocarbon is different from this fluorosurfactant. So this perfluorocarbon is not a bioaccumulant, but however fluorosurfactant is. So we will not confuse, we will remember this here itself. Then the ill effects of this perfluorocarbon, that is the reduced female fertility, then reduced sperm quality of men, and reduced birth weight in babies, and attention deficit hyperactivity disorder. So this is a disorder wherein people, they hyperactively react to even smaller situations. Then prostate and bladder cancer are also the effects of this perfluorocarbon. So this is a brief account on perfluorocarbon. Then come to next topic, the osmosis and reverse osmosis. Friends, what is osmosis and reverse osmosis? We discuss here. That is, osmosis is a process by which water molecules of a solvent tend to pass through a semi-permeable membrane from a lesser concentrated solution into a more concentrated one. That is, from the lesser concentrated solution to higher concentration solution, it will move. So here concentration is the solute concentration, friends. So here if we take a solution of water with a salt, so the water moves from lower concentration of salt area towards the higher concentration of salt area. Then this osmosis occurs through a potential gradient. So as per the natural potential gradient, the osmosis works. Then it is a natural process. So you need not supply any energy externally. Then it occurs during absorption of water from soil by roots and opening of the stomata. So this we will discuss in the next slide. We will keep it pending. Now coming to reverse osmosis. This is a process by which water molecules of a solvent passes through a semi-permeable membrane in the direction opposite to that of natural osmosis when subjected to a hydrostatic pressure gradient than the osmotic pressure. Yes friends, so this is something reverse of osmosis. So we will see how this reverse osmosis occurs in the next slide. Then it occurs against the potential gradient. Yes friends, that is why we need to give external pressure or external energy for this reverse osmosis, and this is an artificial process. So this doesn't occur naturally. Then this is used in the water purification system. So now we can see how the difference between osmosis and reverse osmosis works. So in this figure we can see a salt solution. So these are the salt particles and this is water. So here the salt particles are less here and the concentration is less, and from this to the level of higher concentration the water moves through the semi-permeable membrane, and this same osmosis principles is embedded in the transpiration of water in the plants. So in the roots of plants we can see that the salt level inside the roots will be higher, but however in the outer soil the salt content will be lower. So these pure water molecules, they enter into the root because the concentration inside the root is higher. So that is how by this osmosis process the roots will absorb water molecules. The same works in the stomata as well. Friends, in the leaves the stomata is present, we know that, and in the leaves during photosynthesis excess of water will be present and the salt concentration will be less. But however in the outer atmosphere there will be salt particles. So in order to balance this water from the lower concentration of salt particles to the higher concentration of salt particles, it moves out. So automatically the water particles, they get out of this leaf and they get into the atmosphere. So this is how transpiration and absorption of water takes place in the plants. Now coming to reverse osmosis. Friends, here we can see that a pressure is exerted from this part of the concentrated solution. So here the water moves out of this concentrated solution to the less concentrated solution. So, this is against the potential gradient, because actually the water should move the opposite direction, and to move this way we have to exert so much of pressure which is more than this osmotic pressure. So, basically this osmosis, it will be exerting pressure. So, this water will be trying to rush from this part into this part, but however if you force it otherwise, then it will move from this part to this part, and ultimately when we squeeze all the water from this, only the solute or the dirt will be remaining and the pure water will be available here. So, that is how reverse osmosis will be used in purification of water. So, ultimately pure water is available and this can be used for drinking and other potable purposes. So, this is all about the reverse osmosis. Then come to next one, the lithium ion battery technology. Friends, recently wrapping anodes in the 3D carbon nanosheets, these are treated as a very big invention in this lithium ion battery technology, and this will improve the efficiency of lithium ion battery to a great extent. So, we will understand this only after understanding how the lithium ion battery works. So, here is how it works. So, just like any other battery, it has an anode, it has a cathode and it has an electrolyte. So, we will discuss how this charging and discharging in the lithium ion battery works. Friends, we know that this is the cathode and this is the negative terminal, and this is the anode and this is the positive terminal. Friends, here in the positive terminal, the electrolyte will be the lithium oxide, but however in the side of negative terminal, the graphite will be the electrolyte. So, what happens during the charging? Electricity is passed here, and this lithium atoms that are present in this lithium oxide, they give away the electrons. Friends, we know that lithium has the highest tendency to give away that electron which is present in its outermost shell, and it is having high tendency to become a lithium hole or a positively charged lithium ion. So, once the electricity is passed, the electron will be coming out and the holes will be produced. So, these electrons, they automatically get attracted towards this positively charged anode, and they move from this anode through the wire towards the other side of the cell. But however, these holes or the positively charged lithium ions, they will percolate into this electrolyte, and this will enter into the other side of the battery via this electrolytic membrane. So, both of them, they will enter to the other side, but only the path is different. That is, the electrons, they will reach via these wires, and these holes are the positively charged lithium ions, they enter through this electrolytic membrane. Friends, this electrolytic membrane is made of lithium hexafluorophosphate. So, this lithium hexafluorophosphate, this is permeable only for these holes or the positively charged ions. So, this will not allow electrons to pass through them. So, that is why electrons, they do not have any choice but to come through this wire itself. So, when they come through the wire, automatically electricity will be passed, and then when both of them come to the other side of the electrolyte, so here one mechanism occurs. That is, here we know that these are present with the graphite particles. So, this graphite, this will hold the positively charged lithium ions and they will be firmly holding them, and as a result of that, these electrons which come through the wire, they will not merge with the lithium ions. So, these electrons and positive ions, they will not merge together, they will be separate here. So, now they will be having the tendency to merge, but they cannot merge because of this graphite, but they will be merging once they are allowed free. So, now we remove the power source. So, when we remove the power source, what happens? This power source will be removed, and now the electron traffic will be free, and now the electrons can move the other way round in this wire. So, they readily do that, as also because they are attracted by this positive anode. So, readily these electrons present in this graphite side of electrolyte, they move through this wire and they come to this lithium oxide part of electrode, and this positive lithium ions, they automatically get percolated through this and they also reach lithium oxide electrolyte. But this lithium oxide electrolyte is not holding the atoms and electrons anymore. So, now the merging occurs. So, this merging is nothing but discharge of the battery. So, this split and remerger is the charging and discharging of the lithium ion battery. Friends, but however, there is a problem here. This anode of lithium ion battery, it is made up of aluminum metal. Friends, this aluminum metal will expand on contact every time the charging and discharging takes place. So, this increase or decrease of volume and sudden increase or decrease of volume is of dangerous. So in order to avoid that, researchers have come out with a technique, that is, instead of aluminum, they are using this manganese selenide, and this manganese selenide is not used as a metal as a whole. The nanoparticles of this manganese selenide are used as anode, and these nanoparticles, they are embedded via the carbon nanotubes. So now what happens? The surface area of anode increases because more and more electrons they can get attracted to the increased surface area of this manganese selenide, and moreover they are very minute in nature. So even if they increase or decrease in the volume, that will not be of much difference for the battery, and moreover they are stored under this carbon nanotubes. So whenever they increase or decrease in the volume, these carbon nanotubes, they will act as a protective cover. They can increase, but they cannot expand over and above this carbon nanotube cover. So this is how the lithium ion battery are made further efficient via use of carbon nanosheets and this manganese selenide nanoparticles. So this is all about the lithium ion battery. I hope you have understood. Come to the next one, the zeolites. Friends, zeolite is a catalyzing agent, and recently it was found that this catalyzing agent is more useful for converting biomass into biofuel. So this is of great use for the production of biofuels. Coming to zeolites, friends, zeolites are microporous aluminosilicate minerals commonly used as commercial adsorbents and catalysts. So here we can see how they are porous, and these are used as catalysts and adsorbents, that which absorb the pollutants and other particles. Then 10 grams of zeolites can have an internal surface area of the size of a soccer field. So because of porosity, they will be having a greater surface area. Just in the last slide, we discussed how the nanoparticles of manganese selenide, they have higher surface area. So these minute particles, they automatically they get higher surface area. This is a simple physics. I hope you will understand. Then their cavities make them useful in catalyzing chemical reactions and thus saving energy. So instead of giving high energy, if we introduce the chemicals into these pores, then these pores, they will create a small environment wherein the chemical reaction can occur smoothly. Then one important application is conversion of biomass into biofuel. We will see how a biomass is converted into biofuel and how that is facilitated by these zeolites. Then zeolites contain oxygen atoms in their crystal structure, which already carry a proton, and then they form hydronium ions through the interactions with the water. Friends, you won't understand like this. We discuss in detail. That is, we take a zeolite particle here, and we know that it has so many pores, and these pores, they will be having molecules of aluminosilicate, that is Al2SiO3. You agree with me? And this Al2SiO3, it has 3 oxygen atoms. And friends, these oxygen atoms, when they are introduced into water, they will get slightly negatively charged, or they will get slightly a negative ion like characteristic. So why this occurs? Friends, this aluminum is weakly holding this oxygen. So because of this weak holding, so this oxygen, it requires some stronger positive holding, and this very tendency to get attracted towards a stronger positive holding itself induces a negative type charge. So if only and only if it is having some slight negatively charge, this has the tendency to get attracted towards a stronger positive charge. So that is how the ions function. And now this aluminosilicate is added into water. So friends, in water we know that if we pass electricity into water, the H plus and OH minus ions will be created. You agree with me? This hydroxyl and the protons will be created. So these protons will be positively charged and hydroxyl ions will be negatively charged. Now this aluminosilicate is added to this water which is passed with electricity. So there are more and more aluminosilicates, more and more negativities of this oxygen through this aluminosilicate, and these protons, they have a tendency to attract or get attached to these oxygens which are having slight negative charge. So these more and more protons, they come and get attracted towards this oxygen atom. As a result of this, hydronium ions will be created. Friends, hydronium means H3O positive. So one oxygen, it will get attached to 3 hydrogen atoms and thereby creates a hydronium ion. Friends, this hydronium ion will be very heavy, because we discussed that this oxygen, it has only slight negative charge but not a complete negative charge. So these hydronium ions are formed all over the zeolite, and we know that these have become very heavy. So all over the hydronium ions have been created with 3 hydrogen and 1 oxygen atom. But this heavy is ready to give out some of the protons or some of the hydrogen positive ions. Now we will introduce the alcohol here. So alcohol, we know that this is the structural formula of alcohol and it will be having one hydroxyl ion. And friends, we know that this carbon compound, it will be more stable if it has a hydrogen here instead of this hydroxyl ion. So this has a more tendency to have a hydrogen and become a methane rather than being a alcohol. So alcohol is not so stable compound, it will either burn out or react easily, but methane is a stable compound. So this tendency of the methyl alcohol to give out hydroxyl ions and get protons is advantageous for this zeolites. So we know that zeolites, it will be having hydronium ions all over and this is heavy and it is ready to give protons. So once this hydroxyl ion, it enters into the electrolyte, that is the water medium, so this will split and this will readily get attracted towards this zeolite, and zeolite in turn will readily give one proton to it and proton will be attached to it. So as a result of that, this methyl alcohol, it gets converted into methane. Now what happened friends, this methyl alcohol, it became methane, or the alcohol, it became a fuel. Friends, we know that methane is used as a biofuel. So that is how a biofuel is prepared from this alcohol, and zeolite, it facilitated the formation of biofuel. But now this is not the end of the reaction. So once this hydronium ions, it gives away some of the protons to this alcohol, but however we know that this is a water medium friends, and this water is being passed with electricity. So as a result of that, there will be much more positive hydrogen or the protons present in the water medium, and these protons, they will be ready to once again get attached to the zeolite. So now they get attached and more methyl alcohol molecules will enter, and then these protons will be given up by this zeolite and that will be attached. Then once again methane will be created, and again these free protons, they go and attach to this zeolite. So this is how as a chain reaction, that is, I repeat, so these are positive protons present freely in water and this is a zeolite and it is having hydronium. So now a methyl alcohol enters. So when this enters, it will give away OH minus ion and it will readily accept one proton, and this gets converted into methane. So after this, there will be one place here. So this that is free in water, it will come and get attached. So now this becomes heavy and it will be ready to give the protons further. So this reaction is wherein the biofuel is prepared, and zeolites can be influential and they can act as a catalyst to enhance the biofuel production. So this is how the invention is, and now zeolites can act as a boon for more and more production of biofuels. So this is all about zeolites. Then come to the last part. Friends, chemistry is a very beautiful subject and it is not only related to the chemicals, everywhere chemistry is applicable. So your equations with other person, so your mental balance, so your reaction to the situation, all these are based on the chemical reactions that occur in your brain. So more and more you understand the chemistry, you will understand your thought processes, and once you control your thought processes, you will achieve the zenith in your life. Be it Mahatma Gandhi ji, be it Martin Luther King Sr., Martin Luther King Jr., they have all had one great unique thing, that is, they had the strength to control the chemical reactions within their brain. They had the strength to control the thoughts. So if you control the thoughts, you will win your own, and moreover you will win the world. So do it. All the very best. Good luck friends.